Hello, welcome to TIB. We hope you are doing good. First of all, I would like to thank you for your interest with us to learn big data. Let us understand what is big data all about and what exactly you would be learning as a part of this curriculum. Also, it is very important that you understand what are the takeaway from the course and what you would be able to do as a big data or Hadoop developer once you complete the course. And moreover, you would have heard these terminologies like big data, Hadoop, Spark or other big data ecosystem component names, right? Obviously, you would have observed there is a lot of demand in the job market for big data and Hadoop developer. First of all, let us clearly understand what is big data and what is Hadoop, or what is the difference or relationship between this big data and Hadoop. If you observe, as the volume of data increases day by day, big data Hadoop is doing a drastic change and playing a key role in the current data analytics environment. Big data is nothing but it's a term to use to refer the study of data sets that are too complex for traditional data processing. Let us come to the point. First of all, what is data? Like when I say what is data, it is a very important question that you need to understand. And what is big data and why is it called so? Or what is the role of Hadoop? Or why do we need to learn Hadoop? Or what is the significance and scope of this data analytics? I knew obviously you would have these questions in your mind. So let me start from the very basic question, what is data? So data is nothing but it's a simple fact or figure. It's nothing but it's a pieces of information, or it's a raw, like let's say for example when I say 25, it's just a data, it's a raw format, it doesn't give meaningful information, right? So when I say 25, I don't know what exactly is 25, or when I say TIB, I don't know what exactly is TIB, right? It's just a raw, right? So let's try to understand what is the relationship between this data and information. Now what I'm going to do is I'm going to add a context to this data. Let's say for example I'm going to add a context age to this data. Now what it becomes, now 25 becomes the age is 25. So it's nothing but when I add a context to the data, that becomes the information. So simply I could say it as the processed data is nothing but information. So whereas the information is collection of processed data that gives a meaningful context, right? And for another example, when I say training institute, so what TIB becomes, the TIB becomes this particular raw fact becomes the training institute is TIB. So that becomes a meaningful information, right? So data is nothing but the raw format and information is nothing but the processed data which gives you the meaningful information, right? Now I'm going to answer your most frequent question, what exactly is big data? So if you see, when I say data, actually there are three varieties of data we store in our day-to-day life, like structured data, semi-structured data, unstructured data. So when I say structured data, it's nothing but the traditional way of processing, the traditional data that we are storing and processing. It's nothing but let's say for example when I say employee data, what and all I would be storing? I would be storing employee ID, employee name, employee phone number, employee location. So that's nothing but, and so on, that's nothing but the structured data, right? This is what I've been doing so far. Like so far traditionally in my enterprise I would be storing only the structured data in my RDBMS, and the way of processing the structured data is nothing but RDBMS. And apart from this I would be storing semi-structured data, which is nothing but like a kind of notepad, text files, all these things that would be having some sort of pattern to process the data. And unstructured data, obviously the data which doesn't have more pattern to process, or I could say it as images and audio files, video files, all these things. So what I could conclude is, when I have data, it's nothing but I do have a different varieties of data, that is nothing but structured, semi-structured and unstructured data. Now what are the characteristics of this data? When I say this varieties of data, what are the characteristics of data? Now nowadays if you observe, I do have different characteristics of data. If you observe when the world is moving towards the social media and the e-commerce and other the platforms which generates huge amount of data, what are the characteristics that I get out of this data? Like for example I could say it as like when I talk about the social media, how many number of status that we are updating per day, how many number of twitters that we tweets that we tweet in the Twitter per day or per second. Now when I do all these things, obviously I should store and I should process all this information, right? Now when you go, for example, if you search in the Google for any bus information or any bus timing or train timing, obviously no wonder you will be getting lot of advertisement, lot of calls to your mobile, right? So what happens exactly there? I would be storing all this data, and I would be processing all this information in the backend to give the best recommendations and best advertisement to the targeted customers, right? So when you think about all these things, do you think that the data is, data would be very small? No, obviously the data would be very huge in volume, right? And you are not the only one customer, or I am not the only one customer who search this information. Obviously there would be n number of customers or n number of visitors who visit my application, or n number of people in the world who who uses the social media, who searches something in the search engines. So obviously I would be ending up in huge volume of data, right? Now when I say huge volume of data, obviously, like as I mentioned earlier, lot of like terabytes, petabytes, zettabytes of data I would be storing. And apart from that, I would be having, as I mentioned earlier, I would be having different varieties of data, right? And again, the same scenario, and you're not the only one customer, I am not the only one customer, n number of people would be accessing my application at the same time, right? So think about the speed of data which is coming in. So I could just term it as high velocity of data, right? So this is what I call as 3V characteristics of data: huge volume, different variety, high velocity. So when my data falls under this 3V characteristics, I call my data as big data. That's all, nothing more than that. So what are the problems associated with this big data? So when I have this huge volume, different variety and high velocity of data, it is very difficult for me to store the data, and it is very difficult for me to process the data. When I say process the data, getting some meaningful information out of this data, that is what I mentioned as processing. So what are the two problems associated with this big data? It's nothing but storing the data in a very efficient manner, and accessing and retrieving the data in a very efficient manner. So these are the problems associated with the big data. Now if an enterprise carries the varieties of business data, that is big data, obviously they would need a finest way to store and process the data, right? So I'm looking for a solution to store and process such a huge and different varieties of data. So what is my solution? I'm looking for a better solution. I'm looking for a finest way to store and process such a huge volume of data. Now here is our king Hadoop comes into picture, and it has actually conquered a massive place in the market via its significance, or storing and processing big data in effective distributed storage and distributed and parallel processing manner. So keep in mind that big data is nothing but it's just a term to indicate a very huge amount of data, nothing more than that. And what exactly is Hadoop? Hadoop is nothing but it's a distributed storage and parallel processing framework to process the big data. That's all. So I just conclude what is big data. When I have the 3V characteristics of data, I call my data as big data. What are the problems associated with this? Storage and processing in a effective manner. Now what is Hadoop? It's nothing but distributed storage and distributed processing to process big data in a effective manner. That's all. That's all about big data and Hadoop. That's what is the difference between big data and Hadoop. Now I guess I have answered your most frequent question, what is big data and what is Hadoop, right? Now let us quickly have a glance through our course contents, what and all we would be covering in this particular course. So obviously we would start with what is big data, why big data, what is the need of big data processing, and we will be going through different life cycles of any big data analytics project. And then we'll start with Hadoop. We'll see the basics and overview of Hadoop, and then we'll start with the environment setup, like setting up a single node cluster and multi-node cluster. Once we are done with the system, cluster setup, we'll start with the most important component, HDFS and MapReduce, which is nothing but the core components of Hadoop. Like HDFS is nothing but, it's for storage, and MapReduce it's for processing. You remember, hope you remember, I have mentioned Hadoop is nothing but it's a distributed storage and distributed processing platform, right? A framework to process your big data. So HDFS takes care of the storage problem what I have mentioned, and MapReduce takes care of the processing problem what I have mentioned. So we'll be going in a very detailed manner on HDFS and how to store the data in HDFS and how to process the data in which is stored in HDFS using MapReduce programs. We'll be learning what is the architecture of MapReduce algorithms, or how MapReduce model works, and what are the different concepts in MapReduce. And we'll be seeing a lot of examples starting from the very basic like word count program, and kind of couple of log analysis programs we'll cover. And we'll go through Yarn framework, which is nothing but the cluster manager for Hadoop, like how we have to execute the Hadoop, the MapReduce programs, how to submit the MapReduce programs, and how exactly it executes, the Yarn executes the MapReduce program. And then once done with HDFS and MapReduce, we'll cover Scoop, which is nothing but how to ingest the data to HDFS from RDBMS. So basically how to import the data which is resided in my RDBMS, the structured data, to HDFS. And then once the data is ingested, again it's all the traditional way, or the way that we discuss, like MapReduce, how to process the data which is stored on HDFS. So Scoop is nothing but importing data from RDBMS to HDFS, and once done with Scoop, we'll cover Hive. This is a very, very important component, guys. The very effective way of processing the structured data in Hadoop, in a SQL way of processing the data which is stored on top of HDFS. So we'll do a complete deep dive on Hadoop. We'll see a lot of concepts and how exactly Hive works, what is its architecture, how to write the Hive queries, and Hive server and Beeline clients, and how exactly you have to manage the data in Hive, and what are the different schemas, all those things, and what are the built-in functions, user-defined functions, like a complete deep dive on Hive. And then we have to start with introduction to NoSQL. Like when I say SQL, it's all about the structured data and fixed schema, right? So what exactly is NoSQL? Again, this NoSQL is also doing pretty much good in the market. There are a lot of opportunities for this part as well. So it is very important that you should understand what is meant by NoSQL, and why exactly, how should I combine this NoSQL in this Hadoop areas. So we'll cover what is NoSQL and what are the basics and idea behind the MongoDB, the NoSQL databases like MongoDB or Cassandra. And then we'll cover HBase, which is nothing but a NoSQL database, especially for Hadoop. So we'll go with HBase introduction and HBase architecture, and what are the difference between the traditional RDBMS and HBase. And once done, we have to cover the basics of Apache Spark. What is meant by Apache Spark, and what are the differences between Hadoop and Spark, and why exactly we go for Hadoop and Spark. So basically, when I say Hadoop, it's all about the batch processing, and when I say Spark, it's all about the real-time data processing, how we could process the streaming data using a Spark, like couple of basic examples in Spark. So basically the sample programs to understand the advantages of Spark. So apart from Spark, we must cover the other ecosystem components, at least the overview of Pig and Flume and Uzi. Like so these components we are not using much these days in the project, but still it is very important that you understand the concepts of Pig, Flume, and then Uzi, and one of the most important message broker in the market like Apache Kafka. So again, it is very important, so we need to cover the overview of all these other Hadoop ecosystem components as well. And then you would have heard this distributions names like Cloudera or Hortonworks, right? So it is very important that we should understand what is meant by Cloudera, why exactly we should go for Cloudera or Hortonworks. So these are the part of our curriculum. These are the things that we will be covering. Now apart from the curriculum, apart from the course modules, other activities like assessments, assignments, tasks, these are very important. So these assessments and assignments, the test and assignments, these are basically on every module. So this must be completed on every module, like whatever modules we have discussed here. So these are the modules that we are going to see, right? HDFS, MapReduce, Yarn, Scoop, Hive, NoSQL, Introduction to NoSQL, HBase, and the basics of Spark. And so these modules, it is very important that we do lot of assignments on these modules. Like I would be giving lots of assignments, like at least 4 hands-on assignments on each module, and 4 or 5 assignments on each module. Like basically the assignments would be based on objective and based on hands-on. Also you would be getting syntactical based assessments and scenario based assessments as well. And apart from assignments and assessments, it is very important you do a lot of regular homework and tasks. Obviously this tasks are focused more on improving your self-learning. So the task would be would not be based on the syllabus what is there, and it would be more on the topics which I am not covering. So it's a kind of self-learning activity that we would be doing. And once done with the these activities, we must focus on resume preparation and interview, right? So we'll finally as a part of course we will be working on these modules individually. So finally we would be working on 1 or 2 mini projects to just tie up all these components, how to interact from one component to another component, a kind of a whole big data project. So obviously we'll not be able to deal with like 1 TB or 2 TB of data, but kind of sample data, like around like 1 GB or 500 MB or 1 GB of data. So we do have a lot of real-time data here. Let's say for example, let's take TIB applications. Like we do have n number of web applications, right? So we do have a lot of log files which is associated with our web applications. So we kind of take these log files and do log analysis on this data. So we will be working on 1 or 2 mini projects, and we'll sit together and we'll discuss what is your current work experience and what is your current project that you are working on, and how to convert it into a Hadoop project. So basically it's very difficult for you if I give any one project and put it in the resume and you go and search the job or convince the interviewer with the project what I'm giving. So obviously that would be very difficult, right? So we'll sit together and we'll understand what is the current project that you're working on and how to convert it into a big data project. So trust me, whatever project you are working on, obviously you would be having data in your project, right? So let us understand how to convert the project what you're working on into big data project and put it in the resume as a project experience, and explain the same thing in the interviews. So this is what we would be doing as a part of curriculum. And coming to prerequisites, obviously you would be having in your mind like what and all I should know already to learn this big data. So should I learn Java, should I learn SQL, up to what level I should know Java, and up to what level I should be good in SQL. So you see, you don't need to worry about the prerequisites. Don't worry about all these things and don't think too much on these prerequisites. Yes, it is mandatory that you should have at least good understanding on Java and SQL. Not only Java, any one programming knowledge, but we would be proceeding with Java because Hadoop has been built on top of Java. But if you have idea on any one programming knowledge, that is pretty much enough. We will be able to manage, and good understanding on SQL. But even though if you don't have any of these prerequisites, you no need to worry about anything. From the day one, from our side, we would help you to learn this prerequisites by yourself, or we'll connect you with the trainers. We do have a lot of trainers. We'll help you to learn this prerequisites before we could proceed, or when we are doing the course. That you no need to worry about much on these things. So don't think about don't think too much on these things. If this overview, whatever I have covered so far, and if I have clarified all your doubts and gave you enough confidence to proceed, so obviously you could join this. This may change your career, because there are lots and lots of opportunities for big data and Hadoop, right? So thanks for watching. You will get the syllabus, either hard copy or soft copy. You will get the syllabus, and yeah, all the best. We'll see you in the next class. Thank you.